My job in this project is to characterize natural hydrogen and methane trapped inside metamorphic rocks. These gases can be trapped inside minerals in what we call fluid inclusions, as you can see in this image here. Nice examples of fluid inclusions observed at the optical microscope. Fluid inclusions are tiny cavities filled with paleogeological fluids trapped in the metamorphic history, in this case, of the rock. What you can see here is a rock in thin section at the optical microscope. You can see the scale here, 20 microns, so we are looking at a very small detail of this rock. The rock is composed of a mineral called olivine, which is cut by these veins of serpentine and magnetite. You can see inside the olivine, interestingly, these very nice trails made of very tiny bubbles of gas that we call fluid inclusions that host methane and hydrogen. These fluids can be very ancient, very old, up to millions of years, and remain trapped inside this rock since their formation and migration. It's interesting because these methane and hydrogen, these energy sources, were produced by the same process that formed these veins inside the rock, these veins of serpentine. And my contribution in the project is to provide constraints on the chemical composition of these fluids and the distribution of natural energy sources like natural hydrogen and methane inside metamorphic rocks, which are potential energy sources for life in the deep biosphere. Part of my job is done in the field, where we collect rock samples to study. And then the second part of my job is in the lab, where I spend most of the time to characterize the rocks we collected at the optical microscope, looking for fluid inclusions, and then after this to extract these fluids mechanically through protocols that we developed here in the lab. After this extraction process, we can then analyze the chemical composition of the gases and, for instance, identify methane or hydrogen trapped. What motivates me the most in my work is the side of exploration, a process where we are exploring nature, rocks, and identify things that were not observed or analyzed before in all the aspects. So from when we are in the field looking for the perfect sample to collect in a mountain, when we are at the microscope, for instance, looking for the perfect fluid inclusion, or when we are about to do an analysis and we never know what we're gonna get. All of these aspects of exploring and understanding things that were not understood before is really motivating my work.